Let's see who's online. GM. Sorry, y'all, I overslept. But I'm here. Slightly underprepared. I'll give it a couple minutes and see if anyone else trickles in. GM simple, GMTP. Oh man, okay. Alright, I don't have any slides prepared. Would you guys rather me run through the developer forum, or would you rather me do a 10,000 foot overview of the OP stack? I could do either one. And I can also leave that in chat. Also, am I coming in okay? I didn't check or change my mic at all, so hopefully it's working okay. They'll be there in and they're gonna be on Discord. We have 3 new developer support engineers and 1 developer support manager. Some personal news: I am moving into a solutions engineer role. So I'm still gonna be working with you guys, but we're gonna be rotating more of the DevRel engineers in. I can get a formal introduction to the group next week, and maybe we'll even do like a Google call too. I don't know how we handle it, but yeah, it's been busy on ramping folks, and busy kind of filling this new role. So we're kind of in that transitionary period. Both are good. Okay. Cool. Right on. I'm gonna grab. Oh, also, okay, never mind. I'm gonna grab a Figma file. Fig Jamboard. GM, here she go. Like I told TP and Simple, I am running a little bit behind today. I don't have any formal slides. We're gonna do a quick 10,000 foot overview of the OP stack. I'll probably run through some developer support questions. We do have a much larger developer support team on the DevRel team now. We have built the team to have 3 developer support engineers and 1 manager, excuse me. And I'm going to be moving more into like a solutions role. I can chat more about what that is, but it's, to put it simply, I'm doing more like partner work and handling chains. So that's kind of the focus. But I'll share this again. You guys can hop in here. And actually, I'll give you edit privileges. I don't know. I changed the edit privileges. I don't know if the link changed, but you're actually doing. Sorry, I didn't mean to share that. Okay, so the OP stack. What is the OP stack? Let's jam on it. So, at OP Labs, we are service providers to the Optimism Foundation, and we build a blockchain. We build a layer 2 blockchain, right? So, build these blocks. How do we produce these blocks, We are, one of our key tenets is that we have a minimal difference from Ethereum. And so with our minimal difference to Ethereum, our structure of our node is similar to Ethereum. So what does it look like? Our OP node, our rollup node has a couple components, right? And I know that you guys are familiar with it, but let's see if we can define them. So like Ethereum, we have the consensus layer aspect of the node, and that's OP node, right? And then we also have, let's change the color here for the execution layer, right? And this is OP-Geth. And they talk to each other. These two work together to form one rollup node. You can think of this. Let me delete this. This is a two-way communication. And it's connected by the engine API. And also, if anything comes up, if you have any questions as this comes up, so just please drop it in chat and flag it, or I have Discord open too, if that works, but chat's probably better if you have any questions. Or you can even just drop questions directly into the document. Cool. So anyways, we have these nodes, and like these nodes, we have multiple on the network, right? These nodes, they all talk to each other, and they form our P2P network. So they talk to each other. Let me change these arrows because they go both ways. No, I guess. So the consensus layer, they talk to each other. But now with SnapSync, this is more of an off-the-cuff, I'm not totally prepared program, simple. So I thought might as well just go over what the OP stack is and how it kind of works at a high level. And then just kind of open it up to any questions as you guys have. So before SnapSync, we had the OP node really was only talking to each other. Now that we have SnapSync, OP-Geth, once you enable that peer-to-peer connection, they also talk to each other. So how do new blocks get produced on this network? What we have, which you may or may not be familiar with, is another node. But this node is special. And why is it special? It's got a privilege. It's called a sequencer node. And what makes the sequencer node more privileged than all the other nodes on the network? What the sequencer node can do is it can create new unsafe blocks. It can create the new, most recent blocks. So when transactions on the network are sent to the sequencer node, they put them into their mempool, they process them, and then they make new blocks. And then now you have this L2 network here, right? Okay, so you have this L2 network. And the sequencer node is putting out these, right? Boom. But that's cool. All right, so we have a sequencer node, and they're taking all of the transactions from here. It's privileged. It's making new unsafe blocks. But that's just a regular blockchain, right? That's an L1 privileged blockchain. There's not really any benefits of this over, like Ethereum, right? So where does the roll-up aspect come from, right? That's the question. And of course, as many of you are familiar with, the roll-up aspect of the node comes from the fact that we derive our security from the L1, which would be Ethereum, right? And I'll change the color to denote that this blockchain is actually Ethereum. So these are L1 blocks, these are L2 blocks, and then how do these unsafe blocks that are produced by here, how do they get these secure L1 properties that we're always talking about? So we talk about posting batch transactions and state roots to the L2, and that's how we derive security. But what does that look like in practice? In practice, there are a couple other players in this game. So we have two more services. One is the OP Batcher, and the other one, I'll change the color again. We'll give this one orange, I guess. Is the OP Proposer. Also, please let me know if I'm coming in through, or if you're having trouble understanding me, feel free to drop any questions anywhere. So the OP Batcher is actually connected to OP Geth, and the OP Proposer, I think, is it connected to the OP node or OP Geth? I forget. Don't quote me on this aspect. But what these services have, special abilities, is, so it's like, we've created these unsafe blocks, but we want to make them safe, or we want to finalize them by deriving the security from Ethereum L1. So what do? The Batcher takes all of the transactions that are produced by the sequencer node, and it goes and it posts them onto the layer 1 blockchain. Great. So these are being posted to the L1 blockchain. What does that mean? That means that this L1 blockchain has state from the L2, and all of these L2 blocks derive its state from the L1. And don't take these arrows too literally, or where they're pointing to too seriously, because it's just more of a general illustration. So this is Ethereum L1. We'll give it gray, and this is the L2. Cool. All right. And I guess I'll turn this color something else. There we go. That makes sense, right? Okay, so the batcher takes all these transactions, they post it onto the L1, and then every node on the L2 network, it derives its state from the L1. So all of these nodes, they take a look at the L1 and they say, this has state posted by the batcher. I am going to use my derivation pipeline, the rules in there, to derive it and make the L2 blockchain. So all of these nodes then do that, and then they create these new L2 blocks. And the L1 will always be the source of truth. So that's a pretty straightforward movement. From the L1 to the L2, it's pretty simple because you can read the L1. However, the L1 has no concept of the L2. So how do you get any transactions from the L2 to the L1? And that's where the OP proposer comes in. Additionally to posting our batches, we're also posting state roots. And these state roots are a commitment to the blockchain that they're saying, hey, this is my view of the state, and this is what I believe it to be true. So when you go through the withdrawal process, and I'll actually grab a document for you guys all. So when you go through the withdrawal process, which is outlined in this blog, you initiate it on the L2, and then you go through this challenge period where you have to prove your transaction on the L1 by comparing it to the state root. So does this state root match up with what the rest of the L2 network is thinking, and is it valid? And if yes, and it doesn't get challenged for 7 days, you're good. You can finalize that message, and then the message passes from L2 to L1. So that's the gist of that. And then what's changed with fault proofs, and what I don't know if I actually was able to forward it over to you, Simple, but it's not just a 7-day window anymore. Yeah, so the challenge period can be a minimum of 7 days, but it can take up to 10 days after the user proves the withdrawal. So I'll drop that in the chat too. So that's just something that's coming with fault proofs, that there is the potential of the challenge period being longer. I don't know if that's how it's going to be set in stone, but I think this is how it works, because if your withdrawal is part of the state root that's being challenged, the challenge process needs to finish before the state root can be deemed valid. So anyways, that's that communication between the L2 and the L1. So it's like, these are the on-chain components, these are the off-chain components. And then we also have, let's say this is like a security node. We also have these monitoring services. And these monitoring services, they take a look at one of these nodes, and they're making sure that everything on the blockchain has a valid state. So like, what are these monitoring services? You can find them in the mono repo. So if you go to the mono repo, you can see, where is it? Chainmon. Looking it up. Here we go. These are the monitoring services you can attach to one of your nodes to take a look at the network and make sure that it all looks good. At the moment, because fault proofs aren't live on mainnet, you're relying on the sequencer to be posting the truth. Okay, so if you still are relying on the sequencer to be the source of truth, how do you derive the security from the L1? That doesn't sound like it's secured from the L1. What's nice about this whole thing, I'm gonna have to move all this down, is that there's a set of contracts in between, and I'm probably there's some contracts on the L1, and there's contracts on the L2. The contracts on the L1, they're all deployed, and if you've gone through that process, you should be pretty familiar with it. But there's one called the Optimism Portal, and this is the main smart contract that crosses these domains. So when a transaction on the L1 happens to the Optimism Portal, it emits an event, and that's the event that the L2, like all of these nodes, derive into this state. So it combines it with the unsafe state and what's on the L1 to make this L2 blockchain. It just emits an event, and then these off-chain Go services read it and derive it. And they all have the same consensus rules, so that's how we get consensus across the network. Cool. This is Portal. What I was going with that is that if the sequencer is a bad actor and it's not accepting your transactions, maybe you want to start a withdrawal, maybe you need to change a liquidity position on an L2, or just move some funds one way or another, you can always interact with the Optimism Portal directly on the L1. All of these nodes will then derive that state, and then it will be on the L2 state. So that's your safety, that's your safety hatch, that you can always do that, so you can feel confident with both exiting or moving your funds. So yeah, cool. That was my very off the cuff, I woke up 5 minutes ago before this started, 10,000 foot overview of the OP stack. Does anyone have any questions? Does anyone have any questions about the OP stack in general? And I'll give it a couple minutes. I know there's a bit of a lag here. Check Discord too. I'm sorry, I got distracted. I was reading your message on Discord TP. He said, should make sure that those cross-domain messenger addresses are the same. Just a quick call out, if you're interacting with any of these contracts, if it's the L1 or the L2, yeah, can we obtain relevant information about the roadmap for the OP stack? Sure. All right, cool. That's fun stuff. Okay, what features do we have? TP, I'll get back to this question, and I'll see if I can find it. We want to make sure that they're using proxy addresses, and that's not the implementation address, because that could be very problematic. So, roadmap for the OP stack. People would get mad at me if I gave you a date. Proofs. Oh, and I don't know why I lost my camera. Let's see if I can get my camera back. I don't know why it's not working, but you know what? You're just not going to be able to see me, and that's fine. Can you guys still hear me? I hope that's still the case. Okay, cool. So next up is fault proofs. Where do we stand on fault proofs? We are going through our Sherlock audit. Oh, here we go. Cool. Fault proof contest. This is in progress right now, I think like the actual audit has um, concluded, and now we're reviewing all of the results and implementing the changes in the code. So I can drop this for you guys all. That means fault proofs are getting their last bugs fixed on OP Sepolia. It'll probably go through a little bit. It'll go through some more testing to make sure that everything works as expected, and then they should be arriving on mainnet. I don't know, by the summer. But don't quote me on that. But I'm pretty confident it'll be by the summer. Then, what do we have next? Okay, so what else is in the pipeline? Custom gas tokens. There's also custom gas tokens, and I think that this is more of a, I don't know. The custom gas tokens is kind of a mixed discussion for me, and I'm gonna drop this link for you guys too, because custom gas tokens and all of these experimental features that are in the specs. So it's like in the specs. If you look at the specs, there's this experimental section. That means like the core protocol developers are still either speccing it out or working it out. So you can see the fault proofs, custom gas tokens, plasma, interop, securities, council safe. And you can see that there are open threads here with the core protocols who are answering, core protocol engineers who will be answering all these questions. Okay, yeah. So yeah, custom gas token's pretty straightforward. The only change is you can't use the optimism portal. You have to use the L1 token. So you use this, boom, boom. And then L3s. Yeah, L3s are a weird thing to me too, because the OP stack is general purpose, right? You can spin up an L3 on top of an L2 permissionlessly, but we don't have much support on it. And that's actually what I'm trying to find out, like how it should work today. And let me go ahead and grab that info real quick. And just give me 1 second to, give me 1 sec. I'll be right back. Okay, sorry about that. On L3s. So this lays some context on L3s. This is basically just highlighting like this is permissionless. The OP stack can be used. It can be used on L2s as well. And you can do this today. You could launch an L3 if you'd like to. However, it seems like people are running into issues because there's definitely some nuance to the L3 space. Like, okay, yeah. So like, what would you change? So, I think like one of the things that needs to change is like the block time. It probably needs to be set to 1 second. I'm sure that there's other configuration changes that should probably also be considered. The other things that I'm thinking about on L3 is like, okay, what about the batch submission frequency? Should that be changed? Should it be faster or slower? And the okay, some weird echo has appeared. Okay, is the weird echo still there or is it gone? Echo, what the heck? Okay, it's gone. Okay. Cool. So yeah, so the L3's still very ambiguous. I think that we should probably even start a thread on our forum too. Let's see, L3. nothing stands out specifically in a title. But I know there's been some questions on it. So you know what? If you actually see specific L3 questions, guys can do me a favor and just open them directly in Discord and ping them to me. We're gonna get more eyes on there, and we can kind of figure out like how to approach L3s. It's new to me, and actually on my calendar, I'm gonna go to a protocol engineering office hour for, and I'm gonna ask some questions and see what their thoughts on L3s are and how we should approach them. Okay, so what else is on the roadmap? What else do we have in store? We also have Plasma. Okay, so if you guys aren't aware, Plasma was actually something that the founders of the Optimism Collective were working on before they took a roll-up centric approach to the scaling Ethereum. The approach didn't pan out the way that people wanted to back then, but now Plasma's back. We are using it for alternate data availability. So we are having OP stack alt DA, and if you're familiar with things like Celestia, it's a very similar thing. And there's OP stack chains out there that are using Celestia as a data availability layer, and we're providing our own in solution. And there's two tracks to the alt DA. There is the centralized DA and decentralized options. The centralized DA, you're using something more like a cloud server. You could use your own computer, but you could use like AWS to be storing certain data. And this is helpful for, for applications that don't need the same security guarantees as maybe financial applications. So that Redstone, one of the chains in the super chain, just launched with Plasma, and I think there is going to be some more soon. And I don't know if we actually, let's see, log. Okay, yeah, we don't have a blog post on it right now, but soon TM. If you guys want like early access and you want to try these features, again, I suggest going in here, because like if you wanted to spin up like a custom gas token, like chain, like you wanted to launch your own ERC20 on OP mainnet, you wanted to spin up a new L3 with a custom gas token, you could do that today. It's got this setup guide here, which is just something we produced internally, and it tells you like which branch to use, how to change your deploy config to enable custom gas tokens, and then how to generate your configuration files, and then you spin up your infrastructure. So that's available. I'm confident that we should have some basic understanding of L3 and DA. Okay, that makes sense. Okay, that's a good call out. How should I capture this? Okay, let's start a new discussion. Oh, and the other feature that's coming is interoperability, and I think this is the big unlock for the superchain, where it will really become and feel like one chain. It's where it's a bunch of OP L2 stacks can actually talk to each other, and with like 2-second message passing. So that should be a big unlock. It will allow for liquidity from chains to flow to one another very smoothly without needing to wait 7 days and going to Ethereum or using a third-party bridge. So that'll probably be shipping on testnet around the end of this year too. So very exciting stuff. I'm grabbing this link. And you know what? We're gonna actually we're gonna make this an announcement instead. Okay, cool. So simple. If you have specific questions, you can ask them here. And for L3s and data availability, I can try and put together some cursory information. It looks like some people are taking. Okay, so that's just coordination. You can also open up questions here too, because if it's more like core protocol focused, I might like modify the developers forum to kind of, what do you call it? To move some of the core protocol questions here instead. But I don't want to make it too messy because like this repository is really for the OP stack specifications. So it's like it's for the people who are more technical and reading the specs and asking questions about those than like general high level ones. So I'm kind of on the fence there. I'm open to your guys' input. Okay. L3. Let's see if there's any discussion on L3s. To loosen the coupling between an LN and LN plus 1, we could ingest events from multiple LN blocks into the same LN plus 1 block. This would allow even an L3 to have a larger block time than its L2. This could be done in many ways to allow. Okay, cool. So these two are a couple of our protocol engineers, Mark and Zeb, and then this person here, I think they're over at Conduit, who's a role as a service provider. So this is being underutilized, so you guys can ask specific questions here, and I might even ask one after I get off this call, and then if you're not seeing any movement on them, you can tag me on Discord directly, and then I can ping the engineers and say, hey, you have an open question, can you please go answer it? And we can do that. Okay, we're at 40 minutes. Okay, any other questions about the roadmap and features. And if not, I think I'm going to start looking into these. I'm in a call. Okay, what do we got here? Okay, it looks like Sean's handling that one. Does OP-Stack LT chain support threshold BLS signatures? I don't even know what a BLS signature is. BLS signature. Sorry, I'm still here. I'm just reading. Simple, do you have a question about the Celestia hack there? Deploy an OP-Stack DevNet to Celestia. Okay, let's close this one. We're going through some cleanup, y'all. How have we collected information on this matter? Is it possible to provide it to those who need it? Okay, so with the Celestia hack, it's something that Celestia has put together. It's a hard thing to support. I do have some internal information on it, so remind me on Slack. Okay, Internet Computer use BLS signatures. Ping me again on Slack, Simple. Can you do it on Monday? And I can see if I can pass that information over to you. The Celestia implementation is just, a permissionless implementation of alternate DA. It's hard to support because we're not coordinating with the Celestia team as far as I know about how it works. We're just kind of building the OP-Stack. On Discord, excuse me, not on Slack. So let's just take a look at it real quick. So yeah, it sounds like they're hacking our rollup node a little bit. if these are referring to our versions. They look kind of behind. Okay. Yeah, I think that they've just modified the node to post the batch data to Celestia and probably the state roots still to the OP stack. Okay, Ashiko, question: is the interoperability feature for OP-Stack L3 expected to be enabled? You know, I'm not too caught up on interop right now, but I think that is the case. Let's see if anyone has asked about it. Actually, you know what, Ashiko, do me a favor. Can you ask this here? If you post that question here, I can talk to Tyne and see if Mark can answer. Because I'm not sure. All right. So, okay, so TV it sounds like he's got the source of truth there. So it sounds like once fault proofs go live, that's the unlock. So L3s can talk to each other as well if they're built on the OP stack in the future. Yeah, thanks for answering that, TP. Okay. Let's see if we can answer some of these questions. I think it's the most recent. Is it 128 blocks? I'm pretty sure that's right. Yeah. Historical execution, RPC requests. Beyond that, need to go to an archive node. This is right. You need to spin up a new archive node. There isn't a migration process. Just a new sync. See, this one I'm not sure on. Do you guys know the answer to this? OP-geth logs, it seems like it's downloading headers for all blocks available. Shouldn't it only download a chunk of the most recent headers? I'm not sure about this. Let's see if we can find the answer in the docs. Okay, this is how to enable it. Let's see if we can go to Go Docs. Syncing the process by geth catches up with the latest Ethereum blocks. Now they say you have to use a client, consensus client. There are two types of snap sync. The block header to sync up to is provided by the consensus client. Because the initial sync block in the 128 most recent blocks, the node stores an occasional snapshot that can be used to rebuild any intermediate state on the fly. The difference between the snap sync node and a full block by block synced node is that snap sync node is start from an initial checkpoint that was more recent than the Genesis block. Snap sync is much faster than a full block by block sync from Genesis to start node. Use snap. Snap sync works by first downloading the headers for a chunk of blocks. Once the headers have been verified, the block bodies and receipts for those blocks are downloaded in parallel. Geth also begins the state sync. In state sync, Geth first downloads the leaves of the state tree for each block without the intermediate nodes along with a range proof. The state tree is then regenerated locally. What do we have here? However, the blockchain is progressing at the same time and validating some of the regenerated state data. This means it's also necessary to have a healing phase where the errors in the state are fixed. I mean, it sounds like what they're seeing is the normal behavior. And I mean, we use, OP-geth is geth minimal diff. I mean, like, it should be the same. So I think this is probably normal. Okay, cool. All right, cool. Is there any, specific threads that you guys wanted me to review? I know we're coming up on the hour, so I'll probably end it here, and then I'll ask V to add our new developer support engineers, and give them that tag, and then I'll put them in our private TechNERD channel so you guys can chat with them. Other news is I'm talking to some more folks to see if they can join the program too. We'll see if we can scale it that way. But yeah, if there's no additional questions, you guys can just drop them in Discord when you have them, and I can do my best to answer them. But yeah, that's all I have for you guys today. Thanks for dealing with me like oversleeping. I appreciate it. And I'll talk to you all soon.